understand now to some extent the mechanism of aging and how sort of the cellular clocks cause cells to expire, but I've always wondered about where the imperative for that comes from, since the reactions are sustainable, the DNA is replicatable, obviously with some degree of mistakes happening along the way, but where do we find that imperative?
Aging.
Oh, aging.
Yeah.
Yes.
Where do we see sort of that imperative to expire show up in that family tree?
I'm not sure we do understand why aging occurs. I mean, I think we've got a good idea of what the mechanisms are. So there are various cellular processes, the most iconic of which is the loss of telomeres in chromosomes. So these little caps on the ends of chromosomes which basically stop the chromosomes from fraying. And through every cell division, they get lost, and eventually you get to a point where you've got none, the chromosomes start fraying, and you get mutations, and the cell becomes what's known as senescent, which is incapable of dividing once again. So, you know, the best analogy for these is the sort of plastic cap on the end of shoelaces, right? If you lose that, the shoelace frays, and the shoelace stops being.
I wondered why. I thought you were just tying your shoelace nonchalantly.
It's just really, really stiff leg at the moment. I just had to move. Thank you for that planted question. So, I think we've got a good idea of the mechanisms, or some of the mechanisms, of what happens when we age. But it's a very good question as to why it happens. I mean, there's not an evolutionary selective process going on. We don't really know what death is, in the same way that we don't really know what life is. And you know, the best way to look at it is as a transition from chemistry, from biochemistry to chemistry at the will of the second law of thermodynamics. Right? That's a bit hand-wavy.
Well, that's what it says in the Bible.
Right. I think that's one of the apocrypha stories. You know, in non-cellular terms, there's lots of interest in why we continue to exist after we've reproduced. And from a social Darwinian point of view, we've got lots of theories. They are all theories, and none of them is demonstrably correct. I mean, there's things like the grandmother hypothesis, which is that in terms of you know, grandmothers stick around after they're post-reproductive in order to maintain the flow of their genes, which they share in high proportion with their grandchildren, onto the next generation, which is the will of biology.
So you mean the grandchildren are more likely to survive if they're grandparents to reproductive age?
Yes, although it's specifically grandmothers for reasons that I'm not sure about. I don't know the answer to that, in fact, because it's not really my area.
And then there's why sex in the first place.
Yeah, we don't know why sex exists, right? I mean, sex is a perplexing thing from a straightforward evolutionary point of view, on the grounds that it's just slightly absurd to have two individuals. Stop thinking like that. Slightly absurd to have two individuals making one, right? That's not an efficient process. Fun though it is. But again, you know, it looks like, I think the best models, which as we said earlier are probably wrong, but the best models that we have are likely to do with the efficient transfer of energy.